We have to get back to Calculotron, the planet of calculus, 7 light years away.
But how do we get there?
That's a great question, guys. How do we get there?
We don't really know the exact pathway, though.
That's true, but what's the best way to get there?
We can approximate it.
Yeah,
but how?
Taylor polynomials!
But wait, guys. There's tons of asteroids in space. We should probably practice first.
Good idea. Neil, you drive.
So there are 3 things we have to do to dodge each asteroid.
What are they?
First, we have to get the derivative part of the asteroid, then we have to get the function part of it, and then we have to get the factorial part.
Remember, some asteroids aren't as simple as they seem.
Alright, guys, let's go to Calculotron. Takeoff, launching in 5, 4, 3, 2, 1.
Oi, laddies, there's a big rock over there.
That's an asteroid, Daniel. Not to worry, we can solve it.
Build the first 3 non-zero terms and the general term for the Taylor series of f of x equals e to the x centered at x equals 0. Since we are building 3 terms, we need the first 3 derivative parts of f of x. The zero derivative of e to the x is just the function evaluated at x equals 0, and we get 1. The first derivative of e to the x is e to the x. Evaluated at x equals 0, we get 1. The second derivative of e to the x is e to the x. Evaluated at 0, and we get 1 again. Those are our first 3 derivative parts for e to the x.
Now we need 3 function parts for e to the x. Taylor function parts are in the form x minus center raised to the order. The first function part is x minus 0 raised to the 0, which simplifies to 1. The second function part is x minus 0 quantity raised to the first, which simplifies to x. The third function part is x minus 0 squared, which simplifies to x squared.
Now we need 3 factorial parts for the Taylor. Those parts are generally in the form n factorial. The first factorial part is 0 factorial, which is simply 1. The second factorial part, 1 factorial, which is 1. The third factorial part is 2 factorial, which is 2.
Now let's put it together. The general term for this Taylor polynomial is x to the n over n factorial.
We dodged that asteroid.
Arg, mateys, there's another one.
This one looks tougher than the last one.
Find the first 3 non-zero terms and the general term for the Taylor series of f of x equals ln of x.
We need the first 3 derivative parts for f of x. The zero derivative of ln of x is just a function evaluated at x equals 1, and we get 0. The first derivative of ln of x is 1 over x. Evaluated at x equals 1, we get 1. The second derivative of ln of x is 1 over negative x squared. Evaluated at x equals 1, we get negative 1. The third derivative of ln of x is 2 over x cubed. Evaluated at x equals 1, we get 2. Those are our first 3 derivative parts for ln of x.
Now we need 3 function parts for ln of x. The first function part is x minus 1 raised to the 0, which simplifies to 1. The second function part is x minus 1 raised to the first, which simplifies to x minus 1. The third function part is x minus 1 squared. The fourth function part is x minus 1 cubed.
These are the 3 factorial parts. The first factorial part is 0 factorial, which is simply 1. The second factorial part is 1 factorial, which is 1. The third factorial part is 2 factorial, which is 2. The third factorial part is 3 factorial, which is 6.
The general term for this is f of n prime of 1 times x minus 1 to the n over n factorial.
Good job, guys. We've dodged that one.
Holy crap! This one's bigger than me! We're going to die!
We can do it, guys. Let's solve it together.
Go calculus!
Hold on, guys. This isn't so bad. We already have the Taylor series from the first asteroid for e to the x. Let's just use that but make the right changes.
What's different about this one?
Well, it looks like the first change we need to make is build a series for e to the x, but nest x minus 1 to the second.
Yeah, and then we need to subtract 1 from the whole series.
And the last thing we have to do is divide each term by x minus 1 squared.
When we first nest x minus 1 squared, we get 1 plus x minus 1 squared plus x minus 1 to the 4th over 2 plus x minus 1 to the 6th over 6.
Once we subtract 1, the first term goes away and we're left with x minus 1 squared plus x minus 1 to the 4th over 2 plus x minus 1 to the 6th over 6.
Now we divide each term in the series by x minus 1 squared.
This is what we get. 1 plus x minus 1 squared over 2 plus x minus 1 to the 4th over 6 plus x minus 1 to the 6th over 24. And the general term is x minus 1 to the 2n over 1n plus 1 factorial.
We've done it! Je peux maths!
Remember, each Taylor term has 3 parts: a derivative part, a function part, and a factorial part. Is this recording? Okay, say the thing.
Raw footage.
Say it. Say it.
Good idea. Neil, you drive.
Well, first we have to get the derivative part of the asteroid, then we have to get the function part.
2, 1.
Okay, now it says camera shakes, and then Danny, you say guys, there's a big rock. Okay, so ready? We'll just...
Hey lads, there's our asteroid over there.
Okay, Neil, now you say that's an asteroid, Daniel, not to worry, we can solve it.
That's an asteroid, Daniel. Not to worry, we can solve it. But he just said it was an asteroid.
That was the point to say there's a big rock. Just do the same thing, but with rock.
That's supposed to be a big rock. You said asteroid. Laddies, there's a big rock over there.
That's an asteroid. We can solve it.
We don't need that part again. Okay, now stop.
It's coming right at us.
What?
What if we just, like, arg, mateys, asteroid a hole. Do it again.
You're lying.
Arg, mateys, there be another one.
This one is